Have you ever wondered what happens during a redox reaction? Well, buckle up, because we're about to delve into the fascinating world of reduction-oxidation reactions. Imagine two species, each with a hunger for electrons. One is about to lose some and the other gain. This is where our story begins. The species that loses electrons, we say, is oxidized. On the other hand, the one that gains electrons is reduced. This is the essence of a redox reaction. So how do we make sense of this electron exchange? We break it down into half reactions, one for oxidation and the other for reduction. This way we can see clearly how electrons move from one species to another. But hold on, we can't just mix these half reactions together yet. We need to balance them first. We start by balancing all atoms other than oxygen and hydrogen in each half reaction. Next, we turn our attention to the oxygen atoms. We add water, H2O, to balance them out. And then we look at the hydrogen atoms. Here we add H+ to strike a balance. But we're not done yet. We also need to ensure the charge is balanced. And for that, we add electrons, those E symbols, to one side of each half reaction to balance the charge. Now comes the final bit of balancing. We need to equalize the electrons in both half reactions. If they don't match, we'll need to multiply the half reactions by appropriate factors so that the number of electrons in each is the same. And there we have it. We add the two half reactions together, cancel out common terms, and voila, we have our overall balanced redox reaction. Just a quick side note, if we're dealing with an acidic solution, we'll use H+ ions and water to balance the half reactions. But if we're in a basic solution, we'll use O ions and water. So to recap, a redox reaction is all about the transfer of electrons. We identify the species being oxidized and reduced, break the reaction down into half reactions, balance the atoms and the charge, equalize the electrons, and then combine everything back together. Simple, isn't it? Well, as with all things chemistry, practice makes perfect. So why not try a few redox reactions on your own? You might just find them electrifying.